Hello everyone, welcome to this new course on Introduction to Microwave and Optical Metamaterials. I am Dr. Debabrata Sikdar from the Department of Electronics and Electrical Engineering, IIT Guwahati. So in this course, as you can see, we will be discussing about metamaterials, their fundamentals and applications operating in the frequency range of microwave and optical. So what are these metamaterials? Metamaterials are basically engineered artificial materials whose properties, whose electromagnetic properties like permittivity and permeability can be custom designed based on the design of the unit cells. So you do not need to rely on the periodic table to give you a limited set of functionalities. You can design your own materials for any particular purpose within this frequency range of microwave or optical. Though their metamaterials is not only limited to this particular frequency domain only, there are acoustic metamaterials, there are thermal metamaterials which work on different frequency range. But in this particular course, we will only focus on microwave and optical metamaterials, their fundamentals, applications, okay, and how you can actually design application specific metamaterials or their 2D version, that is metasurfaces. So here is the course outline. So module 1 will be the introduction, that will typically have 5 lectures focusing on the introduction to microwave and optical metamaterials. We'll discuss about the classification of metamaterials and give you a brief overview of the metamaterial technology. In week 2 and 3, we'll be discussing more into the fundamentals of metamaterials. There we will cover the basic electromagnetic theory. I hope this all of you have this background of electromagnetic theory. Okay, if not, we'll cover some basics to revise or revisit some fundamental concepts. We'll discuss about the electromagnetic properties of materials and how electromagnetic waves interact in materials. Okay, then we'll also look into Fresnel equations, different optical phenomena like absorption, dispersion, scattering, properties like polarization of electromagnetic waves, and then we'll build up the concept behind the metamaterials. In module 4, we'll go for the theory behind metamaterial design, and we will see how we can use the optical properties of metals and dielectrics, okay, make different composites of metal and dielectrics, mix them up to get some new properties, and then we will go to the effective medium theory approach, something like Maxwell-Garnet theory, Brugman theory, Nicholson-Ross-Ware method. These are different methods that allow you design metamaterials for specific applications. Module 5 will be dedicated towards the electric metamaterials. So we will cover the topics such as metal dielectric composites and periodic array of metallic wires in detail. So we will think and see how things can be done for electric metamaterials. We'll discuss inhomogeneous, uniaxial, biaxial and chiral metamaterials, applications of different resonating and non-resonating metamaterials. In module 6, which will be in week 6 as well, so we'll focus mainly on magnetic metamaterials. We'll start our discussion with split ring resonators, optical magnetic elements and their equivalent circuit modeling. We'll take up examples and applications of magnetic metamaterials. In week 7, we'll cover the module 7 of metamaterials for microwave antennas. So we'll discuss about the modeling of microwave devices using metamaterials, far field focusing with one layer composites metamaterials. Okay, we'll also discuss about microwave antennas with 2-layer wire composites metamaterials. In week 8, we'll focus on negative index metamaterials. So that is where both your permittivity and permeability are simultaneously negative in a particular frequency region. Okay, so there we will see the reversed phenomena in this kind of negative index media. We'll discuss the general recipe for creating this kind of negative index metamaterials, how you can make them and what are the different approaches people have found out. Okay, we'll discuss about super resolution using meta lens. In week 9, we'll focus on module 9, that is on hyperbolic metamaterials. We'll discuss about the fundamentals, see how they can be used for hyperlens imaging, and what are the different active hyperbolic metamaterials. In module 10, in week 10, we will cover metamaterials for electromagnetic cloaking. So there we'll first start with the principles of transformation optics. We'll see how you can obtain electromagnetic cloaking using metamaterials and how you can design metamaterials for stealth technology. In week 14, we'll focus on tunable metamaterials. So there the first things would be like how you can tune this metamaterial properties. We'll look into different methods of tuning like magnetically tunable, electrically or thermally tunable metamaterials. We'll also discuss how you can make tunable metamaterial based sensors and different tuning applications, particularly in microwave and nanophotonic domain. And in the final week, okay, that is we'll be covering module 12, that will focus on metamaterial fabrication and characterization techniques. That will tell you how you can actually make those metamaterials using photolithography, pattern transfer. Okay, you will also discuss the methods of fabrication for two-dimensional metamaterials and how you can characterize those metamaterials. So who can do this course? Obviously the fundamental electromagnetic theory background is needed for understanding the concepts. So I would recommend the final year BTech students, master students, MSc students, okay, final year BSc students, and people who are doing PhD in this particular area of metamaterials and metasurfaces focused on microwave or optical frequency regime will find this course very useful. Also, industry people who are working on this metamaterial and metasurface technologies, particularly in the stealth technology and other imaging or lensing kind of technologies, they will also find this particular course very interesting. So I hope you will enjoy this particular course on metamaterials and metasurfaces on microwave and optical regime. With that, I would like to welcome you to this course and thank you for your attention.